take a look at question number 3. So let's just take a look here. So we've got these 3 vectors, and we want to figure out what the resultant force is. So I'll call this F1, I'll call this F2, and I'll call this F3. And so I'm going to say that this is 10 newtons pointing at 60, this is 10 newtons pointing at 0, and this is 10 newtons pointing at, I'll say, negative 60. I could also say 300, either way you want to do it. So the x and y, this is going to be 10 cosine of 60 times 10 sine of 60. And when I work that math out, that's going to be 5, comma, square root of 3 over 2 is like 8.86, so I think this is going to end up being 8.9 newtons. So let me just double check that. So cosine of pi over 3, because Apple likes radians. Whoops, I meant the sine. Sorry. Yeah, 8.66. So it actually ends up being 8.7. Sorry about that. This, of course, ends up being 10, 0. And this one here ends up being negative 5, 8.7. So let's combine all our vectors. So F1 plus F2 plus F3 is going to end up being 5 plus 10 minus 5, 8.7, 0, plus 0 plus 8.7. Sorry about that. So this is going to give me 10, 17.4 for now. And let's, it says we just want the magnitude of that force, that's just the size. So that's going to be 17.4 squared plus 10 squared. We're going to square root that right there. And that's going to give me 20 when I get my answer. So 20 newtons when I work that out, because that's 10 squared plus 17.4 squared, all under square root. That's 3. And for number 4, a vector. Oh boy. So we got A, which is 5 at 35. And then we got B, which is 10 at 125 degrees. So again, A is going to be 5 cosine 35, B and 5 sine of 35. And then for B, we're going to have 10 cosine 125, 10 sine of 125. That's going to be the method for calculating all this. 4.09 and 2.86. And for B, I'm going to end up getting negative 5.74 and 8.19. We're going to add those up, and then we'll bring it down to, this isn't going to be pretty, we're going to bring it down to 1 sig fig, so we'll just go ahead and do that. So when we work that out, this works out to about negative 1.64, and this one comes out to, let's see, 6, 5, 15, whoops, 0, 1, and 11.05. Oh, that's great. Well, yeah, apparently I have a life. Let's turn that off. Okay, so here we go. I'm getting negative 1.64, 11.05. So when we apply Pythagoras' theorem to this, the resultant A plus B is going to work out to be, we'll square this, and when I take the square root, that works out to about 11. I should say 10, so I'll just make this 5.0. I just want 2 sig figs to really sort of illustrate what's going on. And then the angle here is going to be the inverse tangent of 11.05 divided by 1.64. And we'll take the inverse tangent. So that's given me about, well, I should say the math gives me 81 degrees, but let's be really clear here. We're talking about second quadrant angles here. So math will tell me 81.55 degrees when I do this as a positive number angle. But here's the thing. That's what this would be. I need the angle over here. So what I need to do is I need to take 180 minus this angle. And that's going to give me 98 degrees for the angle. So that's question number 3 and 4.